This problem and all other Calc 152 problems can be found here at Sarai Studies. Link is in the description box below. This is an integration by parts problem, but you always want to try u substitution first, and if that doesn't work, then you do integration by parts. And I recognize it's IBP because there's two things being multiplied together, so that tells me integration by parts. Now, the way that I set up my paper is I start by drawing a box, and then I just split it in two, but I make one a little bit smaller. And the reason why is because for every integration by parts problem that you do, there's two integrals you're going to have to take. And it's a way to keep things organized. So let's go ahead and get started. The first thing is know your formula. So I like to remember it as uv minus v du, where v and v's are on the inside here. Then I do u, v, du, and dv. Now, unlike u sub, the first thing you actually find are your u and your dv. To find my u, I use limit. I ask myself, are there any logs? No. Are there any inverse trig? No. Are there any polynomials? Yes, there's an x. So then my u is going to be an x. What this is saying, basically, we prefer our u's to be logs, and then if there's no logs, then inverse trig, and if there's no inverse trig, then polynomials, then exponentials, and then just trig functions. Then whatever is left is going to end up being my dv, and then you can find your du, which is just the derivative of this, 1 dx, and then to find v, that's the first integral that you have to do. You have to take the integral of dv, and that makes sense because dv is the derivative times dx of whatever v is. So if you have the derivative, which is the result, then to go back to the original function, you have to take the integral of that. So this is the integral of e to the x. We know that is still e to the x plus c. Now in integration by parts, we literally do not care about the plus c's until the end because there's going to be a lot of plus c's, and at the end of the day, they're just going to amount to 1 plus c. So just forget about it. So we're going to say e to the x. Now we have everything we need to plug it into the formula, and that's what we do. We plug it in. So we have x, e to the x, minus the integral of e to the x, and then du is just 1 dx, which is just dx. And this is where the second integral that you have to find comes in. So this, we go ahead and do it in this box to keep things nice and organized. But before I do that, I'm going to drop everything. I'm going to make sure that I know whatever I find here is going to be plugged in here, and I'm going to add a plus c so I don't forget y plus c because it's an indefinite integral, no bounds. So we already know this is equal to e to the x because the antiderivative of e to the x is e to the x plus c. So the integral of this is e to the x. And if you're confused about the plus c's, no matter how many plus c's you have on your paper, there's only going to end up being 1 plus c in your answer. So this is equal to x, e to the x minus e to the x plus c, and that's your answer.